spanning the volumes, or an application spanning the volumes, or a file system. Or maybe this volume is the database, this volume is the log files for the database, so you want to treat them together. And the host set, we often think of VMware or some sort of cluster or another clustering solution, the nodes in a cluster. So a couple of things in terms of host sets. Now, the other thing too, let me kind of flip back. Let me talk about this. Well, actually, give me just a second. I'll talk about, well, I changed my mind. I'll talk about something else in a sec, because we're on the screen here for host sets. A couple more things with host sets. Now, some of these bullet items we've already talked about, but let's recap them. When virtual volumes or virtual volume sets are exported to a host set, the volumes are exported to each member of the host set with the same LUN number, which is critical for certain clustering failover solutions. So I talked about that one. Second one, an individual virtual volume can be exported to members of the host set as private storage. Basically, that's what I said. Even though a host is in a host set, it can still be treated as a regular host to export and unexport private storage. I already talked about the second bullet item here. The third set, a host set can only be removed if there are no volumes or volume sets exported to the host set. So if you remove a host set, let's say, for example, you decide, okay, I want to get rid of this host set. What they're saying here is if there are any volume sets or volumes exported to the host set, you have to unexport any volumes or volumes sets from the host set. And then you can remove the host set or delete the host set. Now, when you delete the host set, you're just kind of destroying the relationship, if you will, between the host and the host set. So the hosts are still out there if you delete a host set. And then any private storage will remain exported to those hosts if you delete a host set. Okay. And in fact, the fourth bullet item here, removing a host set does not remove the individual private storage exports from the host. In other words, the hosts are still out there. If you delete the host set, the hosts are still there, and then any private storage remain exported to the host if you delete the host set, delete a host set. If a host is removed from a host set, all private storage remain exported to the host. I just mentioned that. A host can be a member of more than one host set. It's possible. And you'll see reference to host sets in SSMC and the CLI output. Now, a couple more things in terms of the VV set or the virtual volume set here. Couple of things is to create a new volume set using existing volumes. The volumes could be exported host or host set. All right. Now, there's a little bit of a catch here, though, I want to talk about. What they're really saying here is, let's say you have two volumes and you want to put these two blue volumes in a volume set. These volumes could be exported to a host or host set or not. So if they're not in a exported, sure, you can put them in a volume set. That's fine. You can put these two unexported volumes in a volume set. Okay, that's fine. Now let's say, they're also saying here, let's say these two volumes were exported to a host, or maybe even two different hosts. But let's say in my example here, these two volumes were both exported to this green host. They're both exported just independently. They're not part of a volume set. So let's say these are exported to this host. What they're saying here is that if these volumes were exported, you could still put them in a volume set. That's fine. So the volumes, to create a new volume set, using existing volumes, the volumes could be exported or not. So let's say these volumes were exported to this host. You could put them in a volume set. All right. But here's the thing. Remember, when you put these volumes in a volume set, initially they were exported independently, like regular volumes. All right. So what happens if you put exported volumes in a volume set? You give the volume set a name. All right. Then if they were exported when you put them in the set though, it's pretty easy, and I'll show you how to do this. Like let's say you have volumes in a volume set, you want to export them, unexport them. Let's say you put these volumes in a volume set after they were exported, then you click on the volume set name and you say unexport them. Well, when the volumes were exported, they weren't a member of a volume set. So it won't work. So there is a little catch. You can put volumes in a volume set that are exported independently. But to kind of treat them as kind of a volume set as a unit, the first time around, this is going to incur downtime a little bit if you decide to do something like this. You'd have to unexport them individually, then re-export this as a set. And then from there, you could unexport and re-export as set. So there is a little bit of a catch. Technically, you can put volumes that are exported in a volume set, but you can't really treat them like a volume set at that point. The other thing too I want to mention here, and it's not really in terms of volume sets, this probably later this morning we're going to talk about snapshots. If you have volumes in a volume set, you can actually make snapshots at the volume set level, which are what we call consistency group snaps. So if I want to make a snap of these two volumes, you can snap them at the volume set level, which is nice as well. The second bullet item, when creating volumes in SSMC or the create VB command using count, the volumes are put in a volume set by default. This is actually, there's a little caveat here I've got to tell you. Remember yesterday, what they're talking about here is, let me flip back here. When we were talking about, I showed you how to create volumes yesterday using SSMC. Remember when you create a volume using SSMC, you give it a name and so on. Let me clean this up a little bit. Use a CPG and a size, etc. But then there was this volume grouping. And if you put in a count greater than 1 here, say you want to create 3 volumes here. In SSMC, by default, volumes are not put in a volume set. So let's say you want to create these 3 volumes. Here's the name of the volume. Remember, when you create a volume using a count, or I'm sorry, multiple volumes. Like, let me flip back. This volume here, they're naming TPVB_14. They say create 3 of them. The first volume will be .0, .1, and .2, the 3 volumes. By default, in SSMC, you have to supply a volume set name here if you want to put them in a volume set. The default is don't put them in a volume set. Now, I don't know if a lot of you worked with the command line yesterday, but with the command line, when you create a volume, I'm sorry, let me flip around. I know I'm flipping around here. When you create a volume from the command line with the create VB command, you can use this option, count. So here they want to create 3 volumes, count 3 volumes. Now by default, when you create a volume, do a count greater than 1 with the create VB command, it's going to create the volumes .0, .1, .2 and put the volumes automatically in a volume set for you. So it's a little bit different. In SSMC, when you create volumes using a count, the volumes are not put in a volume set. When you do a create VB with the -count option, the volumes will be put in a volume set with the default name. All right. To remove a volume set, it can't be unexported. So if you want to delete a volume set, you can. But it can't be exported to a host or a host set. This bullet item, removing a volume set, does not remove the volume. So if you remove a you take these 2 out of, you delete this volume set, the volumes are still there. To remove a volume, it must be a member of a set. I'm sorry, if it is a member of a set, it must be removed from the set first. Basically what they're saying here is if you want to delete this volume, follow the red bouncing ball from this volume set, you want to delete it, From the disk, it has to be taken out of the volume set, remove it, and then delete it. A volume could be a member of up to 8 volume sets. And then you'll see tomorrow, we think about volume sets kind of, so we can put them in a group, so we can export them and unexport them as a group. But there are other uses we use. We use administratively volume sets for other features like priority optimization. And so tomorrow, and also adaptive flash cache, which you're not going to be using. But tomorrow we'll talk about PO, so you'll kind of see they have a different business purpose with PO. And when we're going to talk about this tomorrow as well, this bullet item, when you create remote copy groups for remote replication, the volumes at the local site and the remote site are automatically put in volume sets. Yesterday we talked about the fact that when you create a volume, there's an attribute you can set, restrict export to one host. So what they're saying here is, let's say these 2 volumes in the volume set, this volume here, the top volume, had that restrict access. It could only be exported to one host. If one of the volumes in the volume set has that attribute set, the volume set could only be exported to one host, even though only one of the volumes have the restrict export to one host attribute set. So any questions up to this point? So here's some kind of finer details on host sets and volume sets. So you'll see reference to host sets and volume sets in a number of places. Like, these are just a few examples. What they're showing you here in SSMC is how to create a brand new host set. And in the GUI, you just click on host sets, and then you click the create button. You're going to give your host, this is one example. They're going to call, this is the name of the host set. You choose the array, you can give it some comments, and then you just click on this add host button and the list of the hosts will come up. You can choose to, here in this example, they add these 2 hosts called Windows Boston and Windows New York City, NYC. Now, so what they're going to wind up doing here is putting these 2 hosts in a host set. Now, these 2 hosts, Windows Boston and Windows NYC, they could have volumes exported to them. That's fine. All right, you can do that. So, and what they're showing you here in the host sets area, this is the name of the host set. They called it Windows Clusters. And they're just showing you here the map view. This is the name of the array. This is the host, this is the host set, and these are the 2 hosts in the host set. Now, you can also, in host sets, highlight the host set. You can create a new host set under the actions area. Edit a host set. Now, when you edit a host set, you can add and remove hosts to the host set, change the name, the comments. You can delete a host set. Now, when you delete a host set, though, there can be no volumes or volume sets exported to the host set. And when you delete a host set, any private storage remain exported to these 2 hosts, if there was any, to these hosts in this host set. Now, probably on Friday, we're going to talk about pure motion. If you want to migrate data that are, the volumes that are exported to these hosts and these host sets to another 3-par array, you can use a feature called pure motion. And you can migrate at the host set level using pure motion or PM. Here they're just kind of showing you an example. They're in the volumes, virtual volume. This is actually, we showed you this yesterday, right? They're in the export area. Remember, to export, you right-click on a volume or right-click on a host and say export. In this example, they were in the virtual volumes area. They're going to show you, this is the volume they eventually decide they want to export. When you export, remember, you click on this add button. And by default, remember yesterday in the lab, the default view here, the radio button is just show me host. Well, if you click on host set, it'll just show you host sets. You can choose the host set or even more than one host set. Now, another example I want to flip back to yesterday, remember in terms of host sets, remember yesterday when we showed you how to add a host in the host set? I'm sorry, how to add a host. You click on the create host button and you give your name. Now by default, when you add a host, the default is don't put it in a host set. There's a little pull down here. You can actually put a host in an existing host set. When you add a host, if you want to put it in a host set, you can do it when you add a new host. Or if this were the first host you want to put in a host set, you can actually type out the host set here. All right. So a couple of, you see host sets, and these are just a couple of examples here. In terms of the volume sets, what they're showing you here is how to create a brand new volume set. Now here, they're in the volume sets area. They already have a couple of volume sets created. They're showing you how to create a volume set, a brand new volume set. And it's pretty easy. You give it a name, some comments. You can choose, then you click on add volume. It'll show you all the volumes here. They're going to create, add 2 volumes to the volume set. All right. And then from there, you can, the volume set will show up here. Now here, they're just showing you, this is the name of the volume set, test app 1. They changed the view to the export. And note here, what I can see from this example, I want to look at this example here. This volume set called test app 1. This is the name of the volume set. There are 4 volumes in this volume set. These are the names of the volumes right here in this 3rd column that are in the volume set. This volume set is exported to this host called CM847. These 4 volumes are exported to this host. The first one is LUN 12, 13, 14, and 15. So these volumes are exported to this host with those 4 LUN numbers. So from a volume set here, you can click under the actions, create, edit volume sets. You can change the name, comments, add or remove volumes from volume sets. You can delete a volume set, but remember it can't be exported to a host or host set. And of course, in volume sets, you can export and unexport it. And we'll talk about snapshots later today, but you can make a snapshot off of the volume sets. What will actually happen is we'll take snaps off of these 4 volumes in this volume set. So we're not going to take one snapshot, but we'll get into that. And you can migrate at the volume set level. Here, what they're showing you is they're in the SSMC. They're under virtual volumes. They're just listing volumes, and they're going to show you how to take a volume and put it in an existing volume set. That's pretty straightforward. All right. And you can work with host sets and volume sets from the command line. The key command for the host sets are create host set. Here they create a host set called host set 1. This is called an empty host set, just naming it. Then they do create host set minus add to host set 1. That's the name of the host set, host 1. They want to add the host 1 to this host set here. This might be the first host. Host 1 might be the first host in this host set or the 10th. I can't tell. This is just a comment, the 3rd example. And they're showing an example is down here at the bottom. From the command line, you can also work with what's called the set parameter. The set parameter means set colon. Like here, let's look at this example. They want to export the volume called VV1 to the members of the host set called ORA host set with a LUN number of 2. So they say create VLUN, which is a CLI command to export. They want to take the volume VV1 and export it to the host set called ORA host set as LUN number 2. Now I can't tell from this how many hosts are in this host set called ORA host set. There could be 1, 5, 10, I can't tell. But this one volume will be exported to the members of the host set as LUN2 to all of the members of the host set. Now, the members of this host set ORA host set, if any of these, let's assume here this host set has 3 hosts in it. It's possible these 3 hosts in the host set called ORA host set, one of the hosts might have already a volume exported with LUN2. And if you use a non-unique LUN number here, it'll give you an error. You have to try another LUN number. So from the command line, you can do commands like show VLUN to look at the volumes that are exported to these 3 hosts and make sure you've got a good LUN number. You can do show host sets, show your host sets. You can use some wildcards. And from the volume sets, virtual volume sets, the key command is create VV set to create your volume sets. And it's pretty straightforward. Create VLUN, here they're showing you how to export. Here they do create VLUN, the set, ORVs. Now, what they're doing in this example is, let's just read the notes. They want to export the volume set name ORAVs. So they're taking this volume set, ORAVs, to the members of the host set called ORA host set. So they're taking the volumes in this volume set, ORAVs, and exporting to the host set, ORA host set. Now, remember these 10, what they tell you, well, I can tell from this, that these 10 this volume set, ORAVs, must have 10 volumes in it, because they're giving you a LUN number range. They want to take the 10 volumes and export them to the host in the host set, ORA host set, with LUN number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, when you supply LUN numbers here, you can give it a range like 1-10 or 2-4. You could do like, you know, the LUN numbers you want to be 2, 4, 5, 6, 7, 8, 10, etc. So you can use commas and so on from the command line. And there are ways from the command line, show VV set, show me my volume sets in the volume sets, and you can use wildcard. Okay. So it's not a hard concept, I don't think, to understand. It's not, it's not a hard concept. It's probably not, it's not the most, I mean, it's nice. It's nice. It's a nice feature. You don't need a license to do it. So any questions on host sets or volume sets? Anybody have any questions? Okay. So another topic, we're going to talk about dynamic optimization and doing a conversion. Well, although we talked about conversion yesterday. Now, DO, to do what we call dynamic optimization, you need a license. To do a conversion on your 7440, you don't really need a license. Here are the objectives. We'll talk about the benefits of DO. And what DO allows you to do is change a volume's RAID level, set size, availability level, media type in some cases. And we can change a virtual volume's user and copy space. Now, we haven't talked about copy space yet, so I'll come back to there. And yesterday I mentioned the conversion. Like if you have a volume that's fully provisioned, you want to convert it to thin or thin deduped, or vice versa, even though it's exported. So we're first going to talk about dynamic optimization. Now, a little bit of an introduction. We call it dynamic because, and you're going to hear me use the term doing a DO tune. We say tune a volume, do what's called a volume tune. All right. And what DO, it's an optional feature, but you do have the license for it. It enables the following. It's a simple method for online and non-disruptive service level optimization. What they're saying here is the volumes being tuned can be exported or not exported. And the volumes can be dynamically tuned by changing volume parameters, a cost-effective way to manage a large scalable tiered storage array. You do need a license. You can work with using SMC CLI. You can do multiple tunes and multiple volumes. It's a background process. All that said, here's what we're talking about. What DO is going to allow you to do is change the characteristics of a volume, or volumes, multiple volumes. So let's say you have a volume that's RAID, actually, let me flip to the next slide. Let's say you have some volumes that are RAID 1 allocated from your SSD capacity. You want to change to RAID 6. Or you have some volumes that are RAID 5, you want to tune them and make them RAID 1. Or to give you another example, let's say you have a volume or some volumes out there that are currently RAID 5. And the volumes have a set size of 4, which is a 3D1P. And so you want to change the set size. It's RAID 5 currently 4. Maybe you want to change it to RAID 5 set size of 9. So think about this. Anything in a CPG, like it's RAID level, set size, we didn't talk about step size because it's not really applicable. For the availability cage magazine option. Some of our customers use it as well, like, and this is where it's oftentimes used. You may not be using DO a lot, but let's say I have some customers that, let's just kind of have some volumes that are on the nearline capacity, the slower disk, and they want to move it to faster disk to slower disk. Now, you only have one media type. So all of your volumes currently are from your SSD. So what if you want to change your RAID level of volumes, the set size, maybe availability cage to magazine. That's often done in conjunction with the set size. And you might do this down here from a cost, performance, availability point of view. Here's a question for everybody. Type the answer out in the chat room. I think it's a pretty simple question. I think it is. What determines a volume's set size or RAID level or media type, or whether it winds up to be cage availability or magazine availability? What determines that for a volume? Anybody? Come on. I know everybody should know this after yesterday. The CPG that you use to create the volume, right? So before I give you a little bit of specifics on DO, I actually want to flip to a slide really quickly. So to do a DO tune in SSMC, it's pretty easy. You highlight a volume, you right-click on actions, you do a tune. And in this example, this is the volume they're going to tune. It's just one volume. They're going to tune this volume. And what you wind up doing, you can see here, this volume here called TPVV_8. This is the name of the volume. And this is what we call the current CPG. It's this volume. Now, kind of bear with me. I know you only have SSD disks, but this volume here that they're going to tune is allocated from nearline capacity. You can tell that from the name of the CPG. Let's assume here this volume is allocated from 7.2K, the 7.2K disks, and is RAID 6, from the name of the CPG. And then down here, let's assume here that I don't go all the way through. Maybe this customer wants to tune it. The volume is currently allocated from nearline as RAID 6, and they want to tune it to FC capacity and make it RAID 5. So down here, you tune and CPG. Now, a couple things I want to go over here when we come back. I want to go into some detail here, but I wanted to show you really quickly. It's very easy to do a DO tune. You highlight it and do some changing you just give it a CPG here. Details to follow. And it's really easy to do, but it's a really nice feature of this array. One of the bullet items when we were talking about what DO is all about, they use the term a cost-effective way to manage a large scalable tiered storage array. Like, let's say I have a customer that's running out of SSD capacity. They could tune some of the volumes in the SSD, move it to like FC capacity, and move it around, tune it, change RAID levels, move it from different media types, set sizes, etc. So and the nice thing about it is that no downtime. I mean, the volumes can be exported. In other arrays, like if you want to change RAID levels or media types, or you have to, you're looking at downtime, making clones, which are point-in-time copies. This is a really nice feature. Really nice feature. All right. Now, question, does it have any performance impact? And that's a good segue to what I was just going to bring up next. In fact, the last bullet item here, it's intentionally throttled to avoid post IO impact. eventually when you do a tune, let's say you have a volume that's RAID 5 now, and you want to switch it to RAID 1. So you tune the volume, use a CPG. Well, what essentially happens in the background is, you know, let's say, let me kind of write this out here. Let's say you have a volume that's currently RAID 5. You know, you just write it out simply here. You want to tune it to make the volume RAID 1. Well, the volume is currently RAID 5. It's exported. So the 3PAR OS is going to have to relay the data out as RAID 1. So it's going to have to, you know, take the pages within the regions and the chunklets and move it around, tune it in a different manner. So anytime you're doing something like a DO tune, and, you know, depending on what the tune is, I mean, if you're changing the set size and the RAID level, or, you know, whatever it might be, yeah, the 3PAR is having to move, you know, I'm going to call it regions and chunklets. We do what we call region movements within different chunklets on the disks. So yeah, there is some back end work that's being done on the back end disks, right? So I wouldn't say that the performance is, I mean, it's causing some overhead on your disks. It is. But what we call the region movements that are done to do these DO tunes, it says here they are intentionally throttled. And what happens when you do a DO tune, a task is started, and it's a lower priority task. So the answer to your question, Amitabh, is, you know, I wouldn't say the performance impact is zero, but we minimize the impact by throttling it, giving it a lower priority. And remember, from the host perspective, there's no downtime here to do these tunes. And remember, like for a write, the host is just writing, mirror, acknowledging on the front end. All of this is causing back-end overhead. But the good news here is you're not looking at downtime. I have not had any customers ever tell me, and as long as I've been working with the 3PAR array, that when they did some sort of tune, a volume or volumes, you know, that they saw a performance hit, you know. So the impact is negligible. And if you think about the only other option would be like to unexport it, and you're looking at downtime anyway. So, and I haven't seen HP, you know, publish kind of any real numbers. Well, if you do a DO tune, you're going to see 0.007% of an IO hit or latency, or, but so I've got some use cases here. What they're saying here is you've got a volume that's RAID 1, and you do a tune to make it RAID 5 with a set size of 4, which is what they're saying here. Now let me add something here. Let's say this array only had 2 cages. All right. Now what the first example up here they're saying here is you might do this from a cost perspective. You know, remember we talked about volumes. A volume that's RAID 1 is the most expensive RAID level. And they're saying here from a cost point of view, they change the volume or tune it to be from RAID 1 to RAID 5, and it results in X amount of cost. You know, it's free space, you know, which is money, right? So they're saying here, the good news here between this tune of this volume is cost. Frees up space. What's the downside? What's the downside of this tune? Okay, Amitash, can we compare it? You know, to be honest with you, I'm not even familiar with what FastBP is, to be honest with you. I don't think it's, well, you have to kind of talk about, I think you're talking about, that's kind of not really my area of expertise. I can't really compare it, but you guys might want to talk amongst yourselves at some point. I'm sorry. I don't mean to sound to discard your question. I'm just being honest. You know. So okay, couple of couple of things here. Let's talk about this question. They're saying here the RAID. I say here we change a RAID level from 1 to 5, and that results in an amount of saving. The good news is cost, right? What's the downside of this tune? The upside is, you know, it's saving them money, switching the RAID level. Anybody going to answer the answer to my question? Well, okay. I see a couple questions out there. Let's kind of go with the question here. So the good news here is cost, right? That results in X amount of space. But the downside is a couple of things. Well, maybe a couple of things. Performance. RAID 5 has that 4IO backend penalty, right? So maybe they get some results and some savings, but I can't tell with this volume. We're doing reads, writes, whatever. But RAID 5 is a less performance-friendly RAID level, particularly on writes. We've got the 4IO and backend penalty. The other thing is availability. You know, RAID 5 is less highly available than RAID 1. And remember, what else happens here? Remember, my array had 2 cages. With 2 cages, RAID 1, you get this CPG that was used to create this volume when it is RAID 1 could be set up with HA cage. For RAID 5, if I only had 2 cages, when I use this CPG to tune into, you lose cage availability. So RAID 5, in my example, that's why I added this 2 cages here, just to kind of get you guys to think. Now, assuming I have 2 cages in my array total, you know, they lose cage availability when they go from RAID 1 to RAID 5. And it's less highly available, maybe a back-end performance. And then from there, they're saying here, then they have volumes that's RAID 5 set size of 4, and they switch to RAID 5 set size of 8. That's going to result in more savings, because remember, the higher the set size, the data to parity ratio, the cheaper it is. All right, let's look at a couple of the questions we got here. So Eddie, you're asking essentially how to check the volume performance on a store so you want to look at so what I was to build on your question, I was saying, well, maybe they're going to take a performance hit once they do this tune. Well, how can you look at the performance of the volumes to kind of see before and after the impact, or for any volume for that matter? Well, for performance monitoring, whether you're looking at ports, disks, whatever it might be. For volumes, there's a couple of nice CLI commands. A nice command called stat-vlun you can run and give it a volume name. You can use a command called srstat-vlun. And then tomorrow we're going to talk about some reports. All right, so the short answer to your question, Eddie, is there's some CLI commands you could use, which we'll get to tomorrow, and some reports you can look at in SSMC. All right? Kind of before and after. So there are a lot of, you know, performance reports. You might want to look at disks, ports, volumes, cache, reports, and some CLI commands, some stat commands. Bamsi says, can we use this feature at the CPG level? Let's see, to convert all the good question. Well, you have to do it at the volume level. Let me write this out. You have to do it at the volume level, the VLAN level, essentially, or actually the virtual volume level. Or you can do it at the CPG level. You can't do it all of the volumes on the array. You have to do it at the volume level or the CPG level. So let's say, for example, you've got, you know, 100 volumes in a CPG. you can go out and tune the entire volumes in a CPG, and I'll show you how to do that. So you can't do it like all the volumes, but you can do it a volume or volume, multiple volume or volume, multiple volumes, or CPGs. And I'll show you a couple of things here as we move forward here. So here they're just kind of showing you might do this from a cost perspective. And down here is kind of the same, the second example down here. They got some volumes, RAID 1, they switch into RAID 5, and that frees up X amount of space. So they're just talking about some use cases here for DO. Another use case, they got a volume or some volumes that are RAID 6. Now here in this example, they're also on the nearline disks. So they're on the slowest disk, the slowest RAID level. Why is RAID 6 in terms of performance kind of worst case scenario if I compare RAID 6 to RAID 5 and RAID 1? What is the downside of using RAID 6? Yeah, you got that 6 IO backend penalty, right? For RAID 5, it's only a 4 IO backend penalty, because remember RAID 6, we got to bring the data and both parities into cache and recalc them, and then back 3 in, 3 out. So anyway, what they're saying here is maybe this volume is RAID 6 and on the slower disk. So they're saying here during peak period, maybe they want to tune the volume or volumes to be RAID 5, and then they tune them on faster disks here. And then during non-peak period, they tune them back. Now, so what they're saying here is maybe, yeah, you get better. So yeah, actually, they're also saying here, you know, the good news here is performance, but you're also bringing up, I think you're getting better availability when you go from RAID 6 to RAID 1. You know, RAID 1 is better from an availability point of view. Right. So good eye. I was going to ask that. And also these disks, the FC disks here are more highly available than nearline disks. I could change these like to SSDs, but and then one other thing I want to point out in this example, they say they want to tune the volume to a more performance-friendly RAID level, and during a non-peak period, they tune it back. One of the things I'll mention, and I'll talk about this in a second, is you can schedule these tunes. You have to do it from the command line. So but you have to do it from the command line. So like, let's say they have this volume during the peak period is, you know, 5 o'clock every day. You want to tune it, and then at midnight tune it back. I mean, you can do that. I'll show you how to do it manually, but if you want to schedule it, you can do, I'll show you how to do that from the command line. So let's look at this. This is some detail here. So it's to tune in SSMC, it's pretty easy. You highlight a volume and then you right click and tune. You take to this tune volume screen array and so on. Now up here in the virtual volumes area, by default, you can actually change a volume or multiple volumes user space or copy space. Now I haven't talked about copy space yet. This involves snapshots. So I'll actually come back to a DO tune with a copy space snapshot here in a little bit. So disregard this for now because we haven't really talked about it. So let's assume you want to use the user space. This is the volume they chose on the prior screen that they clicked on and said tune it. Now you can actually click on this button, add virtual volumes button, and you know the list of all your buttons. I'm sorry, all the volumes will show up. You can choose multiple volumes here and tune them simultaneously. Now, let's assume they just choose this one volume here. And again, over here, it's showing me what's called the user CPG. Which this is the CPG. I assume here it's nearline RAID 6. So from there, you just go down here in the CPG area, and the default is this radio button, move to another CPG. Now, from there, you can then choose a different CPG. Like here, let's say this volume is allocated from nearline RAID 6, and they want to choose a different FC or SSD CPG. You can choose a different CPG. So clearly if you choose multiple volumes up here, you can do multiple at a time. They'd all be tuned into what's called a new CPG. And then you just tune it or tune the volumes. Now, so here you can tune a volume or multiple volumes in SSMC. You can't tune at the CPG level in SSMC. You have to do it from the command line. The other thing too I want to point out on this slide that's kind of important. So let's say they choose this volume. This is the current CPG. Down here at the bottom when you choose the CPG, you can actually click on this button, current CPGs, because this is the current CPG, nearline rate 6. So essentially, you can choose the same CPG. Now, let's talk about this a little bit. Now remember, in SSMC, let me kind of show you, I want to show you a little demo here to kind of somewhat prove my point. Let's say you have, here I am in Management Console. Early this morning, I created a common provisioning group called CPGX. And the CPG, if I highlight it, you know, it's RAID 5, you can see here. I click on the settings view, CPGX is RAID 5. It was allocated from FC. It had set size of 3D1P. And I created a volume. Okay, and just to show you this, so remember this, my CPG called CPGX is RAID 5, essentially magazine, set size of 4, 3D1P. All right, and earlier this morning, I also created a volume called Demo VV. I'm highlighting it, and you can see the CPG it uses CPGX, right? So I created a volume called Demo VV, and I created a RAID 5 CPG called CPGX. In fact, I'm going to highlight CPGX here. Go back to it. Now, so I essentially have a volume that's RAID 5, set size of 4, 3 plus 1. What if I were to go into this CPG and edit it? And edit the set size from a 4 to a 5, or even change something like the growth increment or change the availability option. I won't do that. Now, in SSMC, note you can't, when you edit a CPG, you can't change the device type or the RAID level, but you can edit a CPG and change the set size and the availability option there. So let's say I do that and edit the CPG. Now, when I edit that CPG set size, you can see up here, it's up at the top here. My CPG, if I click on settings, you can see my set size has changed from a 5 to a 6, 5D1P. But back in the classroom, that's what this is all about, this current CPG. If you make a change to a CPG, in particularly SSMC, which you can only really change like the set size and the availability option. If you want that change to impact existing volumes, you have to tune using the current CPG. So like in my example, I changed the set size. When I edit a CPG, and this is kind of important to remember, a lot of people think, well, if let's say I have a CPG with 100 volumes, I change the set size. If I edit it, it impacts those volumes. No, if you edit a CPG, it will only impact new volumes you might create. So if you want that edit, like the set size, to impact existing volumes, you have to tune using the current CPG. You would only use this tune using the current if you went in and edited a CPG and you want that edit to impact existing volumes. Now, one of the things that HP is encouraging you to do is not really edit a CPG. If you have like in my example, I had a volume that was RAID 5, a CPG RAID 5 set size of 4. to do a tune, you can go in and create another CPG, right, with the new characteristics and tune into a different CPG, to another CPG. In SSMC, like I just showed you, when you edit a CPG, you can only really change the availability and the availability option and the set size. You can't change the RAID level, the media type. But in the old GUI management console that you're not using, when you edit a CPG in management console, you can change the media type from SSD to FC, or you can change the RAID level from 5 to 1 and the set size. You can pretty much edit everything in a CPG in management console. In SSMC, you can't really change that much. Now, from the command line as well, you can use the set CPG to change the RAID level, the set size, the availability options, even the media type. So you can use a command called set CPG to edit a CPG, and you can do a lot more edits in management console in the command line than you can in SSMC. And it's important, if you do that, to remember to tune using the current CPG. All right. So one of the questions, let me go back here. Somebody was mentioning, yeah, Bamsey was saying, can you use this feature at the CPG level? Oh, wait, no, let me see. Which one? Well, one of the questions was, kind of recapping here, one of the things I told you is you can do some tuning of the volume level. So here in SSMC, you can only do it at the volume level. Now you can do more than one volume, it's just volume. Volumes are more than one level. If you want to do tunes at the CPG level, you're going to have to use a command called tunevb. All right. And I'll show you that in a second. So it's pretty straightforward to do some tunes in SSMC. And in fact, Eddie, I think this is actually this kind of helps you with your question in terms of performance. This is an example of what's called a exported volumes performance report. And this is a report I'll show you tomorrow in SSMC. You can create your own reports. Now what they're doing is showing you a report, what's called the real-time exported volumes report, performance report. And this is a real-time report. They're using this as an example. This is kind of the report as it displays in SSMC. What they're saying here is they had a volume exported to a host. And the volume was initially allocated from the slow nearline disk, 7.2K disks, and was RAID 5. And this is, the report, real-time report. And when it was allocated from the slower disks, the total IOPS was about 2,000 IOPS, kind of, online. And then they did a tune. They tuned the volume. And when they did a tune here, they essentially did a tune to tune it to faster disks like the 15K FC from nearline to FC, and then change the RAID level from RAID 1 to 5. And during the tune, after the tune, the performance almost doubled. The IOPS doubled. So, here is one example of one of the reports you could look at. This somewhat answers, this is one of the answers to your question earlier. Just kind of an example. So they're showing you here from a performance point of view. That's one example. And you can do DO tunes from the command line. You can use the tunevb user CPG, give it the name of a CPG, and then string out volumes here. This key command is tunevb, and it'll start a task. Now, there is, I can't remember who it was that was asking the question about, can you do the, and actually it's Vamsi. There's a command, or with the tunevb command, there's an option -CPG you can use. And you can kind of give it source and target CPGs. So if you want to kind of tune volumes all the volumes in a CPG, rather than do it in SNC where you have to do a volume or click on all the volumes you want, you can do it from the command line at the CPG level, giving it a new or a current, a new or the current CPG to tune volumes, multiple volumes simultaneously, but it has to be done at the CPG level. And the other thing too, I want to point out here, they mention here in this note a CLI command called create sketch. There's a really robust CLI command you can use called create sketch to schedule a lot of things. Like you can use, what they're telling you here is you can use create sketch in conjunction with the tune VB command to, like if you want to schedule the tunes, like remember that one example where they wanted to tune it during a peak period and then tune it back. You can use the create sketch command in conjunction with the tune VB to schedule them. And this, although this create sketch command is good to know about, because like we're going to get into snapshots as well. What if you want to create a snapshot of a volume, or you want to resync a physical copy to a base every 2 hours? So this create sketch command is used in conjunction with a lot of CLI commands to like schedule snapshots or schedule a DO tune. The create sketch command doesn't work with every CLI command, but it's nice to know that if you want to schedule the DO tunes, you can use that in conjunction with the tune VB if you want to schedule a tune. And yesterday we talked about converting volumes, like if you have a fully provisioned to a thin provision volume, convert thick to thin to thin dedupe to thin, back and forth. It's pretty easy to do. And what you can do is highlight the volume and convert it. You're probably not going to be doing a lot of this because all of your volumes are thin deduped anyway. Now, but it's pretty easy to do in SSMC. You can highlight a volume, and the screens are very similar to the DO, because the actual algorithm to convert a volume is similar to the algorithm the 3Parse used to do a DO tune on the volume. All right. So what happens when you convert, you just choose volumes. Like in this example, they're going to take this one volume called ESX62. Now it can be exported or unexported. Now this volume is a fully provisioned volume. And then they're going to convert it. Well, they're going to convert it to thinly provisioned. So up here at the top, you have conversion types. So clearly, fully provisioned, well, let me give you the conversion types. You can take a fully provisioned volume and convert it to thin. All right. You can take a thin and convert it to full. You can take a thin volume and convert it to thin deduped. And you can take a thin deduped and convert it to thin. So it's kind of a sliding scale. You've got a fully provisioned, a thin provisioned volume, and a thin deduped volume. So you can take a fully converted to thin, a thin to full, a thin provision to thin deduped, or thin deduped to thin provision, or vice versa. You can't take a fully provisioned volume and convert it to thin deduped. You can't take a thin and convert it to full. If you want to do that, you'd have to take it full to thin to thin dedupe, or thin dedupe to thin to full. So you choose a provisioning type based on the where you want to go to and from. You can choose multiple volumes, but you have to choose all volumes of the same type. Now what happens when you convert, you see down here this area called retention, the original volumes. The default is what we call a delete, which basically means take the volume that are fully provisioned and convert it to thin or whatever you want to do. Delete means just convert them. But you do have some options here, like if you want to let's say you have a fully provisioned volume, you want to convert it to thin. but you want to keep the original fully provisioned volume, like for testing purposes. The default is delete just means convert. If you want to save the original volume or volumes and then convert, you can do that. Here you can save it with the original volume with a prefix or give it a new name. You have a couple of options here to save the original volume. The default delete just means convert it from fully provisioned to thin. And by default, when you can convert a volume down here in the CPG area, the default is what's called a current CPG. So here they take this volume ESX62, which is fully provisioned. They're just going to convert it to thin. And current CPG just means convert it from fully provisioned to thin. But if you click on this button here, move to another CPG, a list of CPGs will come up. And you can choose a different CPG. Let's assume this volume up here, ESX62, over here in the current CPG, it's kind of blocked out here. The current CPG is FC_R1, so it's FC RAID 1. So they want to tune it from full to thin provision volume. And then they click on this, move to another CPG. They use a different CPG. If you choose a different CPG than the current CPG, it'll convert it and DO-tune it at the same time. So if you want to convert and tune, you can choose a different CPG. But if you just use current CPG, it just means convert it. And you can do conversions from the command line with the tune VV command, the same command you use to do the DO tune. We use the same tune VV command to convert it. And you can use the schedule to create schedule to do this, but normally you don't schedule a tune. I'm sorry, you don't schedule a conversion. You might schedule a DO tune, but you don't schedule a conversion. But you can use create schedule with tune VB. Manoj?
Yeah, question is when we are converting this, what effect it has on the host?
Well, it's similar. The algorithm is similar to, is very similar to the DO tune I just talked about. Because in fact, you can see here we're going to use the same CLI command to tune and convert here. So the algorithm it uses to convert and tune is very similar. It's moving regions around or pages within regions, maybe on different chunklets, and the conversion a little bit different. But in answer to your question, like I said a little bit earlier when we were talking about DO, anytime you're moving regions in within different chunklets or laying data out, like for example, if you change the RAID level with DO tune, it is hitting the disks. The algorithm is moving stuff around on the disk. That is going to have some. It's not zero. The impact is not zero, at least on the back end. On the back end, though, this is all back end stuff, DOs, conversions. So when you ask me, kind of, well, what's the impact on the host? Like I said a little bit earlier, we don't really publish any numbers per se, but so it's, I can't really give you a specific number. Well, you can expect X% of a IOPS hit or latency going up a little bit because it depends on the tune, what else is going on the array. Are you doing one volume? Are you doing 100 volumes? What is the tune? Are you converting it to
Hello?
Okay, raise your hand if you can hear me. Can you? Okay, everybody raise their hand if you can hear me. Okay. I apologize for that. We've had some issues in the past couple weeks with our virtual classroom and the audio portion. I should have told you that Monday, but actually, in fact, it was my fault because I sat on my headset on my cable. I'm sorry, and I clicked the button. So okay, I'm trying to get okay. So let me get back to what I was saying. You know, Minaj, your question was essentially, you know, what's the impact on the host? The good news here is you can do these online, no downtime. You know, other arrays you can't. You can convert. You can't change RAID levels. You're looking at downtime. The good news with both of these, we call them online, dynamic optimization, no downtime. One of the bullet items at the beginning of this chapter was the DO tunes and the conversions are somewhat of a background process and intentionally throttled to minimize the impact on the host, the front end impact on the host. As I mentioned earlier, when you do a tune, whether it's a conversion or a DO tune, you know, the task is started with a lower priority. So we do everything we can to minimize the impact from the host from the host perspective, lower priority, throttled, etc. But you know, again, you know, one of the things with this array is one of the main selling points of this array is our thin provisioning. It's very thin. The ASIC that does a couple of things, a handful of things. And the ability to do things like convert and do these DO tunes online, no downtime. So, you know, well, I do have some customers, and I have, you can always do things like this. You might want to do things, anything that might impact your host IO. Like even on the back end, like if you're doing DO tunes or you're migrating, which we haven't even talked about, to another array, things like that particularly in the back end. When I say back end, I mean the disks on the array, the disk interfacing ports, those 6 gig SAS ports. You know, everything needs to be taken in consideration, big picture, right? You know, even a back end DO tuner conversion, yeah. You know, is not zero impact. So anything like that, like a conversion or a migration or a DO tune or AO, which you're not using, could possibly be done during non-peak periods. It's probably better to do that. But you know, the thing about, like, if you think about not so much conversion, well, actually conversion, and maybe not apply to you, but I have customers that are doing a lot of fully provisioned volume, full provisioning, and they run out of space. They do some number crunching and say, well, man, if I converted these to thin or thin deduped, they're going to free up some space. They need to do it right away. The same with the DO tune, right? Like let's say you have some volumes that are RAID 1 right now and you're running out of space. You can do a quick DO tune to change some of the volumes to RAID 5. That's going to free up some space right away. So if you can do things during non-business hours or non-peak periods, good. Sometimes you don't have that option. And again, it's kind of, I haven't really seen HP publish any numbers per se, but I've had, you know, customers give me testimonials that say basically when they do tunes, not so much conversion. I don't have a lot of people converting all the time, fully provisioned to thin provision. I have a lot of customers, particularly, not a lot, but some of, as I mentioned yesterday when we were talking about thin dedupe, that came out. The feature thin dedupe came out with 3ProOS 3.2.1 about a year ago. So I have customers with some of the older arrays who upgraded the 3ProOS, and that's when we introduced thin dedupe. that they wanted to take some thin provision volumes and dedupe them. So they want to convert it from thin to thin dedupe. In your case, you probably aren't going to be doing a lot of conversions, right? Because you're 100% thin deduped right now. You might even not even be doing a lot of DO tunes because all your volumes from SSD, unless you're changing RAID levels or media type, RAID levels or set sizes, you probably won't be doing a lot of DO tunes. But I have I've had a lot of testimonials from our customers who are doing this kind of in their data center. They're moving data volumes from nearline to FC and FC to SSD and SSD, during non-peak periods down to slower, cheaper media and doing possibly conversions, particularly converting fully provisioned to thin from, free up some space. So yeah, it's a nice feature. You may not be using it a ton, but it's nice to know about the conversion in the DO tunes. Plus the host sets and the volume sets we talked about this morning. All right. I apologize for sitting on my headset. Okay, let's do this. We've been at it for a little while. Let's take a quick 10-minute break and we come back. We'll pick up where we left off. See you in 10 minutes. Okay, everybody, this is John, and I am back. Go ahead and put your hands up out there in the classroom if you're back from break. Anybody out there? Okay, we took somebody at the end there said ask for 20 minutes, so we went ahead and did that for the break. Okay, so it's about 9:30 Pacific time. So we're going to talk about one thing, and this is going to kind of a hefty topic. So it'll take a while to discuss, and we'll go over some labs you're going to do. So this topic, the next topic we're going to talk about is called snapshots and clones. So if you have a volume, you want to make a copy of it, or what we call a replica, some kind of a replica. So let's say maybe you want to make a replica of, you know, one of your volumes that's exported to host to do some testing or to use for a backup or just get a good point in time copy, maybe for recovery purposes. You have two choices in 3-part. You know, our replication solutions are the snapshot, or you'll hear the snapshot referred to as virtual copy, a virtual copy. In fact, the if you need a license to do snapshot, and it's what's called the license called the virtual copy or snapshot. Historically, we called our snapshots virtual copy, but just recently, in the past 6 months, HP, like in the GUI SSMC, you'll right-click on a volume, will say create a snapshot. So we're kind of just changing the terminology around as of recently. So a virtual copy or a snapshot is a pointer-based replica. It's not a full copy. So a clone or a physical copy, or you might hear this referred to as a full copy, or a PC for a physical copy, it is a full copy of the data. So it's not as space efficient, if you will, than a snapshot. But there are pros and cons to I mean, there are pros and cons to both. The advantage of the snapshot's not a full copy, so it's space efficient. But there are some advantages to the clone or physical copy over the snapshot. And we're going to talk about both. So here are the objectives. We're going to talk about the benefits, the differences, if you will, between a snapshot and a clone, how to work with them, create them, delete them, export them, etc. Snapshots, some of the rules regarding a snapshot, promote from a snapshot, resynchronize a clone to a base, promote a clone to a base, and you can work with them in SSMD and CLI. So we have two local replication types. Now the reason we refer to these, both the snapshot and the clone, as a local replica is we're going to make a replica of a volume, and it's local in the same array. Now tomorrow, if we want, if we have two arrays at two different sites and you want to copy data from array A to array B, our remote replication solution is called remote copy, which we'll get into tomorrow. But when you talk about a local replica, there are two types, the snapshot and the clone, all right? Now, a snapshot up here at the top is also referred to as a VC or virtual copy. So you'll hear me use those terms interchangeably, and a clone is referred to as a physical copy. So a snapshot is a pointer-based replica. It's not a full copy of the data. And a clone is a full copy of the data. Now, by default, when you create either one, a snapshot or a clone, it's said to be point in time, or PIT. At least initially when you create it. So you're going to hear me use the term PIT, point in time. And so let's get into this. We're first going to talk about the snapshot. Then we'll get into this, some of the clone. So what is a snapshot? It's a pointer-based replica of another volume referred to as the base, or another snapshot, or a clone, using copy on write cal techniques. And you do need a license for snapshot. You don't need a license for physical copy per se. You do need a license for snapshot. Let me explain what they're talking about up here. Basically, the blue bullet item up here. So let's say you have a volume. It could be exported, unexported, thick, thin, thin deduped, SSD capacity, whatever. So this is a volume. So off of this volume, you can make a snapshot. Now, if you have a volume and you make a snap off of this volume,
Threat has been detected.
Like here's my snap here in purple. Call this snap 1. This volume is said to be the base of the snapshot. So the base, when you hear the term base up here, is the source of your snap. So what they're saying up here at the top, referred to as the base volume, you have a volume and you make a snap off of this virtual volume, becomes the base for this snapshot. Now, what you can also do is, with the repar snapshot, is off of a snap, you can make another snap. Like off of this purple snap, snap 1, I can make a snap off of a snap. So in this example, snap 1 is the base for snap 2. So your base could be a snap. Then you can make a snap off of that. All right. And they're also saying here, so your base, think of it like your source, you know, what you're making the snap off of. And they'll also tell you that your base could be a physical copy. In other words, let's say you create a physical copy, which we'll get into later on, of a volume. This becomes a physical copy. Off of the physical copy, you can make a snap off of that, and so on and so forth. And just to throw another wrinkle in this, off of a snapshot, using our snaps, you can actually use the snaps to create physical copies. So your snap could be the base. Off of the snap, I could create a full copy off of it. So your base is essentially the source of your snapshot. Now, one other thing they mentioned, a term they mentioned here, is using copy on write techniques, CAL techniques. I'm going to explain what this means here in a few minutes. CAL, copy on write. All right. Just some functionality here. These snapshots, you can create them independently, remove them, export them, and promote from them. Now, promote essentially means, let me flip back here. Let's say this snap, well, let's use this purple snap. Let's say this snapshot here was a 9 o'clock snapshot. You could use, like if you want to roll the data back, to restore from it, almost like a backup tape. To restore, we call that a promotion, to promote the snapshot. So I'll show you how to work with that. And you can schedule using the create sketch command, and even in SSMC, you can schedule snapshots. So let's say you have a volume, you want to make a snapshot off of it every hour. You know, a 9 o'clock, a 10 o'clock snapshot. You can schedule that in SSMC or from the CLI, and you can even schedule deletion of snapshots. I'll talk about what are called consistency groups. You can make snaps off of a group of volumes, as well as this volume set, and they are thin aware. Basically, you can make snaps off of your thin dedupe volumes. And our snapshots are actually thin. So your base can be a thin volume, and our snapshots are very. I'll show you can create read-to-write or read-only snaps. I'll talk about that. You can make the snap of a snap. And you don't have the virtual lock license, but you can actually use a feature called virtual lock license to mark a snapshot as read-only for a certain period of time, so it can't be deleted. And we have some integration with things like vSphere, Data Protector, and so on. So here, let's assume this blue volume is the base. They make snaps, 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 snaps off a snap. And I'll give you some numbers here in terms of some of the numbers, your limits. Good question. Give me a second here to talk about it. Let me give you, I'll talk about that. Give me a couple of minutes. Good question. So some characteristics some of these bullet items here I'm going to read, but I'll expand on. We're going to record only the changes to the original volume, what we call a copy on,
Threat
right?
has
We
been
make a
detected.
snapshot. You can make a lot of snaps off of volumes. You can make a lot of snaps off snaps, and so on. But you are going to need some space. When I say a snapshot is a virtual copy, it's pointer based, doesn't mean you're going to need no space. You're going to need some space, and we're going to use CPG. We're finally getting to that CPG copy space I've alluded to over the past few days. We're going to use copy space. So Srivastava, this is kind of where I'm going. You'll see how this works. You can use the snapshots to roll the data back. Doing a promotion, you can make read-only or read-write snaps with some guidelines, but your base must be read-write. Now, so most of the, pretty much everything here I'm going to talk about as we move forward here. Here are some limits. For your 7440C, the maximum number of volumes, bases, and snaps is 16, over 16,000. So bases and snaps, 16,000. The maximum number of bases is half of that. So you can have 8192 and then off of those another 8,000 if you have that many. Number of read-write snaps per base volume, 256. So let's say you have a volume. You could make off of that volume 256 read-write snaps. Now, but maximum number of read-only snaps off of a base, off of one base, would be 2048. Now, I'll get into, like, what they're getting at here is, remember, you can have a base and a snap and a snap off of that and a snap off of that and so on. I'll give you some guidelines. But these are the numbers you have to work with. Now, so here's a little bit of a scenario here. I mean, there are other scenarios. This is just one scenario. Let's say you have a volume here. The base volume is the volume, the original base of a snap, what we call a snapshot tree, where these are said to be part of a family, the base plus all the snaps, has to be read-write. So let's assume this is a volume that's read-write. Now, off of this read-write volume, they make a series of read-only snaps. Now, off of a read-write base, in this example, they tell you they create read-write snaps, but you can also create read-write snaps off of your base as well. In this example, they're telling you they just create read-onlys, but you can create read-writes as well. So off of the base, you can make read-only or read-write snaps. Now these snaps here, right off the base, are said to be your layer 1 or leaf 1 snaps. So the snaps right off the base are said to be your layer 1. The base is the source for your snaps. The base is the source for your snap. So if this volume is exported to a host, that's the base. So off of that base. Now a base could be a snap, because like if this read-only snap, I make a read-write off of that, this RO becomes the base for this read-write. So the base is essentially the source of the snapshot. It's just our terminology, source, base, whatever you want to call it. So these are the these snaps are all off of this base here, this read-write snap. I'm sorry, this read-write volume up here at the top. These are said to be your layer 1 snaps, which are off the base volume. Okay, now off of these snaps, the layer 1, like in these examples, they make these are said to be your layer 2 snaps, and then off of that layer 2, layer 3, and 4. So here, read-only, read-writes, base snaps off snaps. and there are some guidelines we'll get into, but down here at the bottom, a virtual copy or snapshot can be read-only or read-write, but the base volumes are always read-write. Now, what they're saying here, the virtual volume, if this is a volume up here, this is read-write. This has got to be read-write, your original base. So this is said to be part of the tree, the same, snapshot tree. And so if I have another volume over here with snaps off, that's said to be part of a different tree or family. Okay, this is just one scenario. Now, let's finally get to copy space. Now remember, and in fact, to kind of show you this, I could show you this via this slide, but I want to kind of show you this via a demo. Remember yesterday, when you created a volume in SSMC, you got to this screen, right? You gave your volume a name, thinly provisioned, you created, or you chose what's called the the CPG, what we call the user CPG, and then you give your volume a size. Now in the additional settings area down here, you can define what's called the copy space CPG, or referred to as the copy space. Now note here, in SSMC by default, the copy CPG is the same as what we call the user CPG. Now, so let's talk about this copy CPG. Back in the classroom, when you create a volume in SSMC, or even from the command line here, you define what's called a copy space CPG. Now, when you set up what's called the copy CPG, you're actually setting up the volume to be snapshotted. Remember, you're defining this within the volume that's going to be the base, right? So number one, you have to have copy space defined, copy CPG for a volume, in order to make a snapshot off of it. So for example, if you would change this copy space to none, when I create the volume, this is the excerpt from the volume, when you create the volume, if copy space was set to none, you could not create a snapshot off of it. So you have to have copy space on a volume defined to set it up, to tee it up to have a snapshot off of it. If it's set to none, you won't be able to make a snapshot off. So number one, this copy CPG sets the volume up to have a snapshot off of it. And you're defining a CPG here. But also, we want to talk about what this copy space is used for. What is it all about? And this actually answers the question a couple of you asked a little bit earlier about where does this snapshot go? Now let's talk about this. All right, I'm going to give you a little demonstration here. Let's say this represents a volume, this little box here. And these purple squares here, these little purple squares here, represent the 16K page of user addressable space. So let's assume, just kind of demo purpose, this is my volume. This is a volume that's going to act as my base. Okay? And these little squares represent the 16K pages makeup of the volume. Remember, 16K page, 120K region, 128 meg regions. And let's assume here, remember, this is kind of for demo purposes. My data in my pages had the data A in it. This kind of represents my base. Now, any volume that's exported to any host, any volume that's exported to any host, all right, there is a little map in the control cache of the array. All right. And essentially this little map points, essentially is a little map of where all the data is for the volume. And I'm generically, for demo purposes, going to call this my VLUN map. So remember, this is going to kind of act as my base over here. I'm going to show you. It's easy to create a snapshot. I'm talking about what goes on behind the scenes here. You know, what goes on behind the scenes. So here's my base. These represent the pages, user addressable space. And let's assume it's exported to the host, and there's a little map pointing to where essentially all my data is. Now I didn't draw every blue line to every page, but you get the idea. All right. Now, let's say you make a snapshot off of this volume. This is going to be your base. So what happens at T0, what we call time zero, at time zero. So let's say you want to kick off a snapshot at 9 a.m. So at 9 o'clock, you want to make a snapshot of this volume. What happens is when you create the snapshot, this map is duplicated in cache. So at T0, when you kick off this snapshot, this map is duplicated in cache. And for demo purposes, I'm going to call this my snap map. And at T0 at 9 o'clock, sorry, give me a second here. I'll change the color here. Screwed that up. At T0 at 9 o'clock, all my data was A, right? So what happens when you kick off a snapshot, the map is duplicated in cache and really kind of has pointers to all the data as of what it looked like when you took the snapshot. And at 9 o'clock, when I took the snapshot, all my data in my bases was A, right? Now, when you kick off a snapshot, when you create a snapshot, at least initially, it's said to be point in time. So if I kick off this snapshot at 9 o'clock, this snap has to reflect the data as of 9 o'clock. All right. Now, when you kick off a snapshot, you know, it's not a full copy. It's just kind of pointer based. So if I could, if I wanted to take this snapshot, and I'll show you how I'll do this actually in a few minutes, take this snapshot to a host and use it for backup if I wanted to or not. But remember, my snapshot, at least initially, is always got to reflect the data as of the time I took it, 9 o'clock. So remember, the data on my base is changing, assuming this base is exported to host, the host is changing this data, deleting this data, and so on. So let's say at 9:01, follow the red bouncing ball here, a minute after I took this snapshot, the host that the base is exported wants to change this data from A to B or something else. Well, what has to happen behind the scenes is we have to take this 16K page, copy it, which remember at 9 o'clock the data was A, right? Then from there, watch what I'm going to do here. We've got to flip up the map here. Remember the red lines here are the pointers for the snapshot, the data as of 9 o'clock. And then the host can change this data from A to whatever they want to change it to A to B, and from B to C, whatever they want to change it to. Now let's say at 9:02, this 16K page change after the snapshot is created. We got to copy the data, flip up the map, and then on the base, this data can change from A to whatever they want to. All right, give me a second. I'm having difficulty. And this data can change from A to X or whatever. And then from there, it can change from X to Z. These over here are called copy on writes. So when you make a snapshot, we don't set aside any space for it. I mean, we just kind of finesse the maps. But what you're going to need space for is after the snapshot is created, if any pages on the base change after the snapshot is created, we're going to have to do copy on writes. We're essentially making copies of the data pre-changed, right? It's changing on the base. We make copies of it as it looked when we took the snapshot. These are called copy on writes. Now, let's now bring into the conversation that copy space CPG. When you define the copy space CPG, you're essentially defining how we're going to save these copy on writes. All right. Now remember, when you create the volume, the base has a user CPG. Remember, when you create it, you use the user CPG to create this base. Now, when you define the copy space CPG for the volume, by default in SSMC, this copy space CPG is the same as the user. But what you could do is have a different CPG for the copy space. Now, this may not apply to you at Bank of America, but think about this. Let's say I have plenty of customers that do this. Let's say I have customers that have SSD capacity, so the volumes are allocated from SSD. But they also have cheaper nearline capacity, right? The cheaper 7.2K disks. And when they create snapshots, maybe they want these copy on writes to go to a different CPG with a cheaper RAID level. All right. So when you define the copy space for a volume that's going to act as the original base, you have to define copy space for it. That sets it up for this volume to be snapshotted, number one. And when you define the copy space CPG, which remember is just a policy anyway, RAID level, set size, media type, it can be different than the user CPG. So these copy on writes, you want to go to cheaper storage, cheaper RAID level, you can do that. Now people will ask me, well, how much space am I going to need for these copy on writes? Well, it depends. I mean, let's say this base volume over here was 16 terabytes. Maybe there were 16 terabytes of data. You make this snapshot off of it. Well, is that snapshot going to be in existence for 5 minutes or 5 days or a year? I mean, in 5 minutes, probably all 16 terabytes this isn't going to change, so you might just need a small amount. If the snapshot is out here, I'm going to keep it for a year, it's possible that all of this could change and I might eventually need 16 terabytes. So people will ask me all the time, well, how much space am I going to need for this? There's no way I could really answer that because it depends on how much, how long the snapshot is going to be out there. What's the rate of change on the base? All right. So, if you read white papers, we'll say, well, you can assume you probably will need about 20% of the base for all of your bases. But that may be too much. That it might even be too little, depending on your setup. So, so that's what the copy on write is. Well, that's a good question. Give me and in fact, that's a good question as well. Drikoth, what happens if you run out of space here? If you'd hold that thought, I'll get to that in a second. You're always thinking ahead. But I'll eventually get to that. But if you run out of space here. So one other thing, I'll get to that. But also yesterday when we talked about CPGs, we talked about them all day, CPGs using CPGs for volumes, grade levels, set sizes, and so on. But remember, CPG is just a policy anyway. So when you define this copy space CPG, it doesn't have to be like a separate CPG. You can just use any CPG that also contains volumes. But a lot of our customers do kind of set up kind of a special CPG for all their snapshots to dump into, but this is just a CPG like any other CPG. Now, I want to come and expand on a few things here in terms of kind of my demo here, but before I actually go into a few more things, I want to push out a little demo here. And I want to show you this. Pretty easy to create a snapshot. Now, I want to show you a few things here. And again, if you have questions, wait till I kind of stop my share here. See this volume here? I'm in SSMC. I have a volume called HP1. See that volume highlighted off to the left? Just to show you this, it is a 1 gig volume. This volume is exported to my host. So this volume is going to act as my base. It's a gig. HP1, if I click on exports, it is exported to my host called Scully Host. It's a gig. And just to kind of show you this, it's exported to this Windows host, right? So here I am in Windows Computer Management. You see disk 1 there, it's a gig, it's mounted. F is the mount point. If I right click and explore, I got 4 files out there. So I'm just setting up my little demo here. I've got a 1 gig volume called HP1 export to my host, and it has some data out there. It's mounted, right? All right. So now here's the volume that's going to act as my base. Now, one thing I want to show you before I even highlight or kick off a snapshot, I'm going to click on actions for this volume and edit it. And I'm going to edit this volume because remember I said to create a snapshot off of this volume called HP1, I have to have copy space defined. And I'm going to go in here under the additional settings here. And what I'm first going to show you is I'm actually going to go out here. Actually, I can't. I know why. That's all right. Well, I won't show you that part. That doesn't really matter. We'll do this in the lab. This volume, actually, I can show you that. Let me show you this. Let me kind of change up what I was going to show you here. The volume does have a copy space CPG setup. It does have copy space, just to show you that. So when I want to create a snapshot off of this volume, highlight the volume, actions, create snapshot. Now, if I didn't have copy space defined, when I click on create snapshot, it's going to give me an error. But since I do have copy space defined, you create a snapshot. Here's the array. This is the parent volume or the base, HP1. Then you can name your snapshot. The default name is take the base and append a date and timestamp to the end of it. And then when you create a snapshot, you can create a read-only or read-write snap. I'm going to make mine read-write. Give it a volume ID. This retention and expiration time involves a virtual lock. And when you create a snapshot, just to show you this, you can create a little schedule. But if you want to create a snapshot of the space every hour, once a day, you can even do what's called a more advanced snapshot, twice a day, once every 3 days. But what I'm going to do here is do what's called a once now, which basically means just create a snapshot right now. So all you really do if you want to create a snapshot, you go in here, choose the base, a couple of other things, and once now and create it. So now I created a snapshot off of my base. Now watch the activity up here at the top. It says create a snapshot of HP1. Now look off here to the left. HP1 is the base. There's a 1 next to it, right? That tells me I got 1 snapshot. And you see underneath it, HP1.15, et cetera, et cetera. That's actually my snapshot. All right. And I've highlighted the snapshot. And one of the things I can do is click on I'm going to change my view. just to show you this in the view, you see that provisioning type is snapshot. So it's pretty easy to create a snapshot. Now, even though here, let me point this out. See the virtual size, 1 gig? I mean, when you create a snapshot, the virtual size, it's, you know, like my base is a gig. Remember, my base HP1 is a gig. So if I take this snapshot and export it to a host, it'll look like a 1 gig disk, but we're not reserving any real space. You know, I mean, it's not a real copy. We're not reserving 1 gig here, setting aside 1 gig. So the snapshot size is going to be the same as the base, the volume that you can make a snapshot off of. But, you know, it's not really setting aside that base. So it's pretty easy to create a snapshot. Now, what I'm going to do, now you don't have to export a snapshot. You can leave it hanging here. So I'm going to show you later on, you might use this to recover. But if you wanted to, let's say you want to take this snap and export it to a host, you could. I'm going to highlight it and export it to my host, just like I would any other volume. And I'm going to choose my host, Scully host. Now, I could actually go out and you can take the snapshot and export it to a different host other than what the base is. I'm going to export mine back to my same host. So if I did this correctly, I'm going to go back to my host. Let me minimize SSMC. So let me go into Windows Computer Management. I'm going to do a rescan here. So if I did this right, I exported the snap back to the host, I should see the same data that was in the base, right? That had 4 files in it. So here we are. I'm going to do a rescan here. So you take the, you know, of course, the operating system, mine's Windows here. But you can see disk 1 is my base, right? Disk 2, I want to do a rescan in a different place because I don't have MPIO set up properly, but I'm going to do a couple scans here. So disk 2 is my snapshot. Now you wouldn't format it or anything, but I'm going to take my disk, my snap online. Then you would just mount it if you wanted to get at the data. Now, give me just a second here. I'm going very well. Give me just 1 second. I do wrong. I'll take this off. Okay, give me just a second. I apologize for this. I don't know why this is happening. The Windows thing.
Threat has been
Disregard what I'm
detected.
doing here. You shouldn't have to do what I'm doing, but all right. So what I'm going to do this time is go into Windows Computer Management. I'm going to do this a little bit differently here. I'm not going to go into standard Windows Management. So I'm going to go and rescan. I'm going to use Server Manager here. me try one thing here. All right. All right, this is what I wanted to say. So you see BISC1 is my base, F. I rescanned. DISC2 is my snap. And actually, I did that really quickly. It was when you go into Windows, you rescan, bring it online, it should mount it. G is the mount point. I right click and explore. I should see the same 4 files as my base, and there they are. All right. So let me show you one more thing here. So my base and I'm going to take the drive letter off of my snapshot. So I'm going to unmount it. And so my base is the drive letter mounted at F. So what I'm going to show you next is how to restore from a snapshot. So what I'm going to do here is go into my base and delete the 4 files. So what I'm trying to simulate here is, I deleted all the files from the base. So remember, I had a snapshot created before I deleted all the files from the base. So what I'm going to show you next is how to take that snapshot and roll the data back. So that's why I took the unmounted the base. I'm sorry, the snapshot. And what I'm going to do here, if you think about this, if you're going to take the data and roll this backwards, you want to unmount it. So I'm going to take the drive letter off of the base. So both the base and the snapshot are unmounted from the host perspective. Now I'm going to go back into SSMC, highlight my snapshot. There it is off to the left. And actions, I'm going to promote the snapshot, which basically means restore from the snapshot. Now I should get an error here. Let me go ahead and do it anyway. It's telling me the promote operation can't be performed because the selected volume is exported. Here's what we're saying here. If you want to take a snapshot and restore from it, promote it, it cannot be exported. Well, mine is exported. So what I'm going to have to do in my example here is unexport the snapshot I'm promoting from. I'm just going to export the snap, and now the snap will be unexported. Now, if you think about it, that makes sense. I mean, if your business goal was to have a snapshot and restore from it or promote from it, it probably wouldn't be exported anyway. Mine was for demo purposes. So now my snap is unexported. So now I'm going to click on Actions, Promote the Snapshot. I'm going to get another error. The promote operations can't be performed because there are no valid targets. Basically what they're saying here is what you're promoting to has to be unexported. Now my base is exported, so I have to unexport that. So I'm going to highlight HP1, unexport that base. So what you're promoting, the snapshot you're promoting from has to be unexported, and what you're promoting to has to be unexported. Now that both are unexported, I'm going to highlight my snap over there, actions, promote it to HP1, that's my base, promote it. It's going to roll all the data back. Now, if I did this right, I should be able to go back, and I'm going to export my base, HP1, and the data should be back because I rolled it back. So now I'm going to take HP1, actions. I'm going to export it back to my same host, Scully host. It's exporting it. So now, back in Windows, I'm going to do a rescan. So this is going to take a second because since my last rescan, I unexported and re-exported. Okay, so now you see disk 1, that's my base. Give it a mount it. Fingers crossed. It's mounted. Right click, explore. I should see the same files back. Oops, wait a minute. Sorry, one thing. Let me do one thing here. Disregard that. Give it a drive letter. Windows, I have to mark it as active first. Now, if I explore, I should see the same data back, and there they are. So you can promote from a snapshot. All right. So I'm going to come back to a few things here, but go back here where we started off, kind of. You need copy space to find. By default in SSNC, the copy CPG is set up to be the user CPG, but it could be different. And what you're doing here is setting up the volume to be a base for a snapshot and defining where those copy on writes are going to go. All right. And it can be different than the user CPG. All right. And this I kind of showed you, right? To create a snapshot, go in, highlight a volume, create snapshot. This I already showed you. You can create a read-write or read-only snap. And you can schedule snaps. All right. Yeah, it's nice. It's a nice option. It is a nice option. It gives you some flexibility, right? It can be different. Now with SSD, you're 100% SSD anyway. You know, you don't have any other cheaper media. But down the line, if you decide, it's actually a lot of people use our nearline disk for that purpose, copy space for their snaps, because they want to keep a lot of snaps out there. Data changes. It gives you an option, right? And here they're just talking about what I just showed you, a promotion. A snapshot can be promoted to any read-write parent with the same virtual family tree. And it basically detects the differences between the snapshot and copies the differences back. And you can also promote from the command line. But what also I want to show you, and this is kind of a segue, even though I just talked about what a promotion is. Let's talk about something here. Let's say you have a base volume. It's just a volume. It's a virtual volume. It's going to act as your base. And remember, your base has to be read. Now remember, off of this read-write base, off of this volume here, you essentially can create a read-only snap. Or a read-write snap. You can do either one. Read-write, read-only, read-write. Now, off of a read-write snap, you can make a read-write or a read-only snap. Okay, so off of a read-write, you can make read-write or read-only. So off of this read-write, I can make read-write or read-only. But off of a read-only snap, you can make a read-write snap off of a read-only snap. You can make a read-write off of a read-only. But you cannot create a read-only off of a read-only. All right. Now here's a question, and I'm throwing it out there for hopefully somebody's going to answer. Why does it not make sense? Well, first of all, you can't create a read-only off of read-only. Why does it not make sense for you to even do that? I mean, you wouldn't, even if you could, you don't really need to do that. Why, can anybody explain to me why you think we don't even allow you to make a read-only off of read-only? Raise your hand if you can. Let's answer this on the phone. Somebody has an idea. And in fact, let me add one thing here. Let's say this read-only snap here was created at 9 a.m. today. It's read-only. Well, yeah, because, okay, since this snapshot here is read-only, this 9 a.m. data, this is the data as of 9 o'clock. It's never going to change. Like a read-write snap, I could export to a host and the data might change. Like if I made this read-write snap here, the red bounce at 9 o'clock, I might export to host and the data might change. But with a read-only snap, the data is never going to change. In other words, this read-only snap is always going to reflect the data as of 9 o'clock. So even if you could make another snap off of this, it would be the same data, the same data point. So there's really no need for you to have to do something like this. Now, sometimes people will say to me, well, what if I want a snapshot, this snapshot export to host A and this one export to host B? Well, you can take a snapshot or like any volume and export it to more than one host. But it's read-only anyway, so you cannot, nor is there any need to make a snap a read-only off of a read-only. So you really can't even do that. So a read-only, you can only make a read-write snap, right? Read-only, read-write. Now, if a read-write, though, remember, you can create a read-only or a read-write. So let's go over here. So off of this snap here, read-write, you can create a read-only or a read-write. But remember, off of a read-only, you can only make a read. Now, for this read-write, I could make a read-only. Okay, now, we just kind of talked about promotion. Now, in my example, when I showed you my promotion, remember, I had a base and then I created a read-write snap. So I took my snap and promoted it here. But one of the nice things you can do with our snapshots is you can promote to another snapshot. In other words, let's say down here, follow the red bouncing ball, this read-only snap, as long as this is unexported, I can promote this to the base. But I can take this read-only snap and promote it to the read. So you can promote it to a read-write snap. In other words, I could take this snap and promote it to here, this snap. I could promote this snap up here to this snap or to the base. Now you can't promote to a read-write. In other words, you can't promote to something that's read-only. So you can promote you don't always have to promote to the base. Now you can actually promote from a read-only or read-write snap. So I could take this snap here, use a different color here, this burgundy color. Let's assume this snap here, read-write down here, is that unexported. Now here's a question. Can I take this read-write snap and promote it to this snap? Yes or no? Type out yes or no. Follow the red bouncing ball. Can I take this read-write snap and promote it to this snap? No, 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 no. You can't promote to a read-only snap. It has to be read-write. So with this snap here, I cannot promote it to a snap that is read-only. So I can't promote to this. Now, can I take this snap and promote to this snap? Follow the red bouncing ball. Yes or no? Yes. You can only promote to read-write snap. Now, assuming this read-write snap is unexported, remember what you're promoting to has to be unexported. All right. I could use this snap to promote to here. Can I promote it to this snap? Anybody? Yes or no? No, because it's read-only. So one of the nice things with our promotion, honestly, is you can actually, a lot of, array solutions, you can take a snap and promote it to this base. But the nice thing here is you can actually take our snaps and promote them up to a read-only snap that's made before. So I can't take this snap here, follow the red bouncing ball, and promote it down. So I can promote my snaps upwards as long as they're read-write and unexported and within the same tree here. If I have another volume with a series of snaps over here, I can't take any snaps and promote them over here. So, and that's actually nice. And let me give you a use case. Let's say you have this base volume and this has some sort of database, right? This is the live database. And so off of this database, you create this snap. Watch what I'm going to box up here. You create this read-only snap here in green. And your business purpose with this, let's say you create the snap, so maybe if you need it, you can restore from this, right? That's your whole business purpose. You want this to maybe be able to promote back to the base for recovery purpose if you need it. That's why you create recovery. That's why you have this whole, you create this snapshot in case you need it to recover here. So you created this snapshot. Let's say this snapshot was created at 9 a.m. on January 1st. All right, so it's read-only. Now, once you created this read-only snap, you created off of this snap, this read-write snap. Now, this read-write snap here, I'll box up in purple. The reason it's read-write is maybe you plan on taking this snap and exporting it to a testing server to use for testing. So it has to be read-write. You eventually want to take this and export it to this testing server to use for testing. But before you take this snap and export it to your testing server, all right, you create, before you export this snapshot here, you create a read-only snap off of this. And your whole goal with this snap is maybe this has your data, and once you're done testing all day, you're going to unexport this and refresh this testing data to roll it back. So you test with this all day long, unexport it, refresh it. Export it the next day, test all day long, unexport it, refresh it. So this ability to take a snap and export it up to a read-write snap is nice. So when you promote, remember in my little demo, I just took my snap and promoted it to the base. But you can also promote to a snap that's made before it, as long as it's read-write and unexported. And you can do that from the GUI or from the command line. You can use the command promote SV. Now, what they're doing here when you do, if you ever do any promotions, here they're doing what's called a promote SV. they're showing you up at the top some what's called some show VV output. They have a volume and a snap off of that. So when they do promote SV, they're naming a snapshot here. This is the name of a snapshot. They didn't take the default name. So when you do promote SV RO2, you give it a snapshot name. The default is take the snap and promote it to the base. But from the command line, you can also use promote SV minus target and work with your snapshots. In other words, if I wanted to promote this snapshot to this, I could, from the command line, do promote SV minus target this snapshot to this snapshot. So by default, when you do promote SV to promote from the command line, the default is promote to the base, but you can use the minus target to work with your snapshots. And in fact, what I want to show you here real quick is I'm going to push out a share here. Remember, in Management Console, let me pull up Management Console, my base is HP1, and I have a snapshot called HP1.15, and it is read-write. Now, if I wanted to, I could make a snap off of a snap. Let me go ahead and make a snap off of that. I'm going to create a snapshot, and I'm just going to take all the defaults. Actually, what I'll do is, yeah, the default is read-write. That's fine. So HP1 is my base. HP.1510 with the 1 next to it is my first snapshot. And then this is my second snapshot. In fact, I'm going to highlight my base, HP1, and change my view to map over here just to show you HP1 is my base. Oh, I'm sorry. What I want to do is show you the copies view. So HP1 is my base here in blue, and then I've got this snap, and then a snap off of this. Doesn't really, I kind of have to go over here. So what I'm going to do here is I'm going to unexport my base. And just to show you, I'm going to highlight the snap off of a snap. This is my second snapshot. Here's kind of the relationship under the copies. And what if I want to promote that snap? I click on Actions, Promote Snapshot. Remember, this is my second snap. I have the base HP1, I created a snap, and this is my snap off of a snap. So when I promote, I could actually promote it to the base or the first snap because it's read, write, and not exported, and both of them are unexported. So you can just promote to what you want to, as long as it's read, write, not exported, and made before it. I won't do it. I'm going to click on Cancel here. But so promotions. And this I kind of showed you. You can promote pretty easy. Now, who was it that asked about what happens if you run out of space? Raise your hand. I can't remember who it was. Who was it? I think it was just Srikath. I think it was you. Well, so let's go back to that picture I was drawing a little bit earlier. Remember all this? You're doing these copy on writes, and this is you define a copy space CPG here. Well, what happens if we need to do a copy on write and you don't have the space? Now remember, when I use the term space, I mean, yeah, you might not have any physical space here. Maybe you run out of nearline space or whatever space you're using, physical capacity. But remember, this CPG here could have a growth limit. So when I use the term run out of space, what if you, for this copy, this CPG, you have set up your copy space, you have a growth limit set to be, you know, I don't know, let's say you set it to be 4 terabytes or something. And it's possible you could run out of space by running out of physical space or hitting the CPG growth limit. What happens when you run out of space? All right, well, it depends on this setting. I'm going to push out a share. When you create any volume, which I'm just going to create a new volume here. You give it a name. You give it a CPG, you give it a size, you know, copy CPG, etc. You could export it. Remember in this policy area, you may not remember this from yesterday. I did mention it very quickly. See this option here, stale snapshots? You could set, the default is allowed. You could set it to not allowed or not allowed. Default in blue there is allowed. Now, so there's a setting for a volume that's going to act as the base called stale snapshots, and it can be allowed or not allowed. So let's go back here. For this base volume, let's say you have the setting stale snapshots set to allowed, which is the default. It's allowed. Here's what happens. Remember, the host is reading and writing to this base volume, and we're gonna try and do copy on writes here. But what happens if you run out of space? With the setting, the default setting snapshot allowed. Let's say here we got to do this copy and write to copy this page to the copy space area. You don't have the space. Basically, the host is going to be allowed to change this page or delete it or do whatever they want to do to change it. But since we can't do a copy on write, your snapshot is no good. It's said to be stale. And when this happens, you'll see in the state, you can highlight the snapshot. It'll come up and say stale. And basically your snapshot is no good because we can't keep track of any changes. Your snapshot can't be current. It's said to be stale. Now, so the default policy, if you run out of space, is let the snapshot go bad. And your snapshots are no good. Now, what happens is, well, nothing really happens. I mean, by default, well, let me take that back. What I mean by that is, if you have a snapshot, like a snapshot that goes stale, I mean, we don't go out and automatically delete the snapshot or anything like that. Your snapshot is just no good. But if you set that snapshot option to no stale snap or not allowed, what we call no stale snapshot, here's what happens. Let's say this volume over here is exported to the host and the host is trying to change this data or delete this data. The host will be fenced, and we need to do a copy on write. We don't have space. The host will be fenced off from changing this data or deleting this data. Your host will be essentially get the equivalent of write fail. Now, so with the settings set, stale snapshots not allowed, what you're really saying here is, you know, if we need to do copy and write, you don't have space, you'd rather have the host get a write fail error and not be able to change the data on the base that we can't keep track of. So what you're really saying with no stale snapshots is the integrity of your snapshot is most important. All right, you'd rather have your host get write fail messages or not change or delete the data on a new copy on write. Now, you know, this host here, excuse me, like in this example, if the host tries to change this data here, follow the red bouncing ball here, we already did our copy on write, so this could change, but any new, what we need to do, any new copy on writes we'd have to do and we don't have the space for, they'd be fenced off and get the equivalent of write error, write fail error. So somebody asked earlier, well, what happens if you run out of space? Well, the answer is it depends on the setting. If stale snapshots is allowed, which is the default, your snapshots are, a snapshot or snapshots go bad, they're stale, and but your host can continue to go on. If you have the no not allowed option, your snapshots are guaranteed to be good. But then your host might incur some downtime or some errors when they try and write to new pages, and we need to copy and write for. Now, most people keep the option stale snapshots allowed because they don't want to incur the downtime on the base. And then they just go out and delete snapshots, create a new one. But one thing I will I will mention here is we use a lot of snapshots with remote copy. This stale snapshots not allowed option might be an option in remote copy. But so I'll come back to this a little bit tomorrow when we get to talk about remote copy. But what happens when you run out of space ultimately depends on this setting. That's a setting on the base that you're making the snapshot of. Okay. And early this morning, we talked about doing a tune of a volume. And this morning, we talked about doing a DO tune on the user space. You want to change the RAID level and set size. But you can also tune the volume's copy space and give it a different CPG. So for example, let me flip around here. Let's say this is the copy CPG NLR5 and you want to change it to a different CPG. What'll happen if you do a DO tune of a volume or volumes copy space CPG? Like if I change this copy space CPG to a different CPG, like, another CPG. This is a CPG. Any new copy on writes will go to this new using this CPG, and any existing 16K page copy on writes will be essentially tuned to the new CPG, which is just a policy anyway. All right, so earlier we talked about DO tunes, and I mentioned I would come back to this. But you can tune a volumes or multiple volumes copy space CPG as well. You can also do that from the command line with the tune VV command. And you can work with snapshots from the command line as well. And the key commands are create SV to create snapshot volumes. You can create snaps off of snaps, snap off the base. You can create read-only and read-write snaps. You can use the promote SV command to promote to the base, or use the -target to promote between two snapshots. But you're promoting to has to be read-write. You can also create what we call consistency group snaps. Either creating what's called a create group SV -RO for read-only. They're taking consistency group snaps off of these 4 volumes. So what happens when you do consistency group snap, you're guaranteed that the data in cache are these 4 volumes are flushed down to disk, so you get good clean snaps on all 4 of these volumes. Another option you could do, which you might do, preferable than doing these independently with the create group SV, is put these 4 volumes in a volume set. And then there's a way you can use the create SV command. I don't know if I have an example. Actually, it's on the next slide. You can do create SV and give it a volume set name, and it'll do consistency group snaps. And you can also use the create sketch command in conjunction with create SV to schedule your snapshots. And to remove snapshots, it's remove VV. You can use the -snap only option. Remove VV, remember, is the command used to remove volumes, but you can use remove VV or -snap only is a nice option to know about. Remove volumes if it's a snapshot only with the naming convention and so on. And the other thing too, really quickly, is I'm going to push out a little share with snapshots. Let's say I have this volume HP1. I'm going to create a snapshot off of it. It has copy space. I'm going to take all the defaults essentially, but when you create a snapshot, you could create a little schedule. So let's say you want, I'll just do a really easy one, an hourly schedule. You give your schedule a name. I'm going to call it schedule snap, hourly, starting at 10 minutes past every hour. And you can actually create a little schedule in SSMC. So I create a little schedule of snapshots up here in the creating a little schedule, and from there in SSMC you can go into the schedules area, and this is my schedule, and you can send the schedule, resume it, delete it, and so on. So you can actually schedule creation of snapshots from SSMC as well. There's a little scheduling capability there. Now, if you want to do things like with snapshots, let's say, for example, you want to create a snapshot every hour, but you just want to keep the last 2 hours. So let's say you create a snapshot at 9 o'clock, 10 o'clock, and 11 o'clock. Then you create one at 12 and you want to delete the oldest one. So you want to create a new snapshot and delete the oldest. And the next hour delete the next snapshot and delete the oldest, what we call a round robin. You essentially have to schedule creation of snapshots and create and schedule deletion of older snapshots. In SSMC, you can schedule creation of snapshots, but you can't delete, I mean, you can't schedule deletion of older snapshots. So if you want to do something like that, create snap and delete old snaps, you have to do it from the command line using create sketch and combination of create SV and remove VV to create the snaps and delete the older snaps. So those are our snapshots. All right. So let's do this. We're going to take a quick 10-minute break, and then we come back. We'll talk about clones really quickly, and then we'll go to the labs and go from there. Okay, I'm going to mute my phone. See you guys in 10 minutes. Okay, everybody, this is John and I am back. Go ahead and put your hands up out there. That's if you're back from break, go online. This is probably the last time you have to put your hand up today. Okay, so after talking about snapshots, which remember are a local replica, and a lot of people like using snapshots because they're space efficient. You know, they're not a full copy and make a lot of snapshots and delete them, and you have some flexibility to save those copy on writes to a different copy CPG if you had different media types. The second type of local replica is a clone or a physical copy. Now, a clone is really a full copy. So, like if I have a 4 terabyte volume, could be thin deduped. And let's say that 4 terabyte thin deduped volume, you're using 2 terabytes of capacity. Well, essentially it is a full copy. You're going to have space for the actual copy of the data. So it is a full copy. So it's not as space effective as a snapshot, but there are some advantages to the clone versus a snapshot. And one is you don't need a license to do a clone. And the other thing too with the clone versus a snapshot, a couple of other things. With a snapshot, you can't remotely use remote copy to replicate a snapshot. So let's say you want to do some remote copy testing of failovers, you would need to use a clone, so you can't remotely replicate a snapshot. The other thing with the clone, you're going to see how this works, is it really is a full copy. So I showed you like a snapshot, you could promote from it, right? You could use it to restore, but it's not really a full copy. You could use a snapshot to restore, but let's say, for example, you had a volume that was a base and it wasn't set up with cage availability and you lost a cage or more than one disk. With a snapshot, it's not really a full copy. Well, with a clone, you could actually make a copy. It is a full copy on a separate set of disks with cage availability, so you actually, redundancy purpose, the clone might be better. And by the way, one thing I want to mention here, this is kind of a tangent, a side item here. In terms of the term cage availability, remember when you use the create CPG command, you're going to have to use the -HA cage option to create it with cage availability, create CPG. I should have brought this up yesterday, but sometimes when I mention cage availability and so on, people will say to me, students will say, they'll say, well, cages what happens? I mean, the 3-part cages can catch on fire or explode, or no, they don't. That doesn't happen. But with a cage, like a drive cage with up to 24 disks, 24 SSDs, for example, there are temperature sensors in your drive cages. Like if you lose one of your fans, overheating condition could happen and the cage could be shut down. So in that case, at least temporarily, you're losing access to up to 24 physical disks. That could happen. For testing purposes, I have customers playing with the cables, the daisy chaining to test cage availability. The cages don't explode or catch on fire or anything like that. But when people are designing an array and making decisions like CPGs and setting up cage availability or not, people want to take into consideration any potential single point of failure. The cage is a potential single point of failure. It is a possibility. But I don't want you to get the impression that cages just fail. There are some conditions where the cage the disks in a cage could basically be inaccessible, like an overheating condition. But there's a lot of redundancy in this array. But in any event, let's get to clones. or full copy or physical copy. A physical copy or clone is a full copy. It's still point in time, at least at the beginning, replica of the base data. Historically, a full copy has been referred to as a physical copy. With the introduction of SSMC, a full copy is also referred to as a clone. And the two terms, clone and physical copy, used interchangeably. A clone duplicates all the data from one volume called the base to another volume called the destination. And any changes in the base cause them to lose synchronization. In other words, it's not really a real-time mirror. You don't need a license to work with physical copies or clones. And you can work with them in SSMC Management Console and the CLI. So let's talk about how a clone works. Let's say you have a volume. Now, your base could be a clone or a snapshot, really. But let's say you have a volume exported to the host. And it doesn't even have to be exported. Going down here at the bottom, you have let's say you have a base. A volume can be thick, thin, or thin deduped. This volume can be exported or unexported. You have to have copy space to find off of this base, and it can be a physical copy or snapshot. And what they're saying here is, what you're essentially going to do, you want to make a copy of this data. The base is the source, right? Your base could be a snapshot of another physical copy or a virtual volume. So let's say this is a volume. X is the base, and you make a full copy of it. What you're going to wind up doing to do this is creating another volume. It's just another volume. It can be thick, thin, thin deduped. We call this the destination volume. Essentially, what you're going to do is basically copy the data from the base to the destination. All right. Now, so when you create this volume, like you do with just like any volume, it can be fully provisioned thin or thin deduped. So it can be different characteristics. Like for example, let me give you an example, because this is just a volume you create using a CPG, right? And so like, for example, some of my customers who do have, mix of media types, their base could be thin deduped, and when they make this copy, they just want it on their cheaper nearline capacity. So they'll create the volume using nearline or FCG. Well, not really, because when I hear you use the term split, let me flip back here. In some arrays, let me kind of address your point. In some arrays, you have a volume, and then you have something like a clone, like a mirror clone, right? So in some arrays, you might have this volume export to a host, so host writes, and this is a real-time mirror, a mirror clone. And like in the EBA, we have a clone called a mirror clone. And essentially, this volume and this clone is like a mirror. So if you wanted to use this, because this is real time, right? This is a real-time mirror in some arrays. When I hear you use the term split, oftentimes in some arrays, like since this is a real-time mirror, you have to split this, or basically get it point in time, right? You split it to get this point in time, so maybe you can use this for a backup or testing, right? Well, with our cloning, it is not a real-time mirror, so you're not going to split it to make it point in time, because our clone is always point in time. So what happens is you create a destination volumes, and I'm going to show you how this works. But don't panic. But it's not really a real-time mirror like in other arrays. And there are some advantages to doing a real-time mirror, but we just don't have it. But let me kind of explain how ours works. You're going to have a volume. It can be different characteristics, different CPG. It has to be that we call it the destination. It has to be the same size or larger than the base. So when you create this volume, it has to be as big as this base or bigger. But it can be a different CPG, different RAID levels, etc. Now, initially, this volume cannot be exported. In other words, when you copy the data from here to here, this initially can't be exported. After it's done, you can export it. And when created and data copy, the destination volumes transitions to a clone. Now there are two versions of the clone. All right. Now let me kind of talk about this or do this via a demo. Now, so what I'm going to do here is it's really easy to create a clone. Let me share my desktop here. All right, you don't need to see that. So remember my volume HP1? Now, that's going to act as my base to create a clone. All right. Now, you see under HP1 there, I've got a volume called HP2. Note here in the settings, it's a gig. HP1 is a gig. So I have a volume called HP1 that's going to act as my base. HP2 is going to act as my destination. So I'm going to highlight, I've already created the destination volume. It's the same size as the base. So I'm going to highlight HP1. That's going to be my base. I'm going to click on Actions and create clone. When you create a clone, the screen will come up. And it's going to say, okay, what's the parent, HP1? It's going to say, well, what do you want to be the clone? Select, it's going to give you a list here of any volume that's as big as the base or bigger that's not exported. Well, I'm going to use HP2, highlight it and select it. So all you do is choose the base, select the clone. You have some choice in terms of what's called the task priority to create the clone, high, medium, or low. I'm going to do a high priority. Now, you see this option here, save snapshot for later resync? The first time I'm going to create my clone, I'm going to uncheck this. All right. So when you create your clone, you do parent clone, and then you click on create clone. Now what actually happens, just kind of watch what happens here. Not much is going to happen. So up here it says creating the clone HP1 to HP2, et cetera, et cetera. Now if I highlight HP2 over here, eventually, actually, now this, let me kind of do one thing here. This is my snapshot from earlier. All right. So actually, you don't really see much back here. HP1 was my base. HP2 was my destination. What winds up happening is it copies all the data from HP1 to HP2, and then your volume HP2 is a base. All right. Now, so back in the classroom, what actually happens when you create a volume, here's what actually happens. You got your base volume, create a volume that's a destination. What actually happens when you do this, and remember the first time around when I created my clone, I said, no, there's that option on the screen to save the snapshot. I said, don't save the snapshot. Now when you do that, don't save the snapshot option, here's what happens. You initiate the copy, you got the destination. What actually happens when you kick it off is behind the scenes, we take a snapshot, use this snapshot to copy the data over here. This volume, the data gets over here. This volume essentially transitions to a base. This snapshot is deleted. And that's it. And you got the data over there, and you can use this. So that's the clone. The first version of the clone. All right. Pretty simple. Create a volume, copy it, and that's it. Use it. Now remember when you create a clone, there was an option on the screen that says Save Snapshot. Now I'm going to, that's the first, so that's the first version. You say don't save the snapshot. there's an option on the screen that says Save Snapshot for later resync. Now here's what happens when you do, and I'm going to show you this version of it as well. You got your base, all right? You're going to have your volume that's a destination. And when you click off the snapshot, here's what's going to happen. Or when you click off the copy, what happens is off of this base, we take a snapshot. Let's say you do this at 9 o'clock. So what happens is off of the base, we take a snapshot. So let's say this is the snap. We do this all at 9 o'clock. So this is my 9 o'clock snapshot. So remember, this has got my 9 o'clock data. We use this snapshot to push the 9 o'clock data over. So the 9 a.m. data is over here. But when you click on Save the Snapshot, okay? Yes. So any changes on this? Well, here, yeah. Let me kind of move forward here because I'll get to your question essentially, because it kind of builds into why we would even do something like this. Because what happens when you click on Save the Snapshot for later resync? When you create the copy, you create a snap, use the snapshot to get the 9 o'clock data over here. But when you save the snapshot out here, this snapshot is kept out there. And there is a relation off of the base, and there's a relationship between these two volumes. When you say save the snapshot, this volume over here will be referred to as a clone. And there's a relationship between these two volumes. All right, still. Now let me show you this real quick, this part of it. So this time, I'm going to do basically the same thing. HP1, actions, clone, create a clone, select HP2 as my destination. But this time around, I'm going to keep that option, save snapshot for later resync. So I'm going to create it. What it should do is create a snap off of HP1. Watch the activity up there. Not very evident, but see where HP1 has a 2 next to it? Down at the bottom, you see that VV, that's the snapshot off of the base, VVCP2. But if I highlight HP2, in the overview, it shows up as a clone. All right, so when you say save the snapshot, there's a relationship. Now here's what's going on here. What happens when you create the clone is we kick off the snapshot, use the snapshot to get the data over here. But then this is a clone of this, of the base. There's a relationship between these two volumes. Now, and then the snapshot is kept out here. Now, why would you want to do something like this in the first place, save the snapshot? Well, let's say your whole business goal is you wanted a full copy of the data every hour. So this is the data as of 9 o'clock, then at 10 o'clock, you want a full copy, 11 o'clock, and so on. Well, and Shrikath, this is essentially answer your question. Since we said save the snapshot, what are we doing via the snapshot? Well, any changes that are happening on the base, we're doing copy on writes. We're keeping track of what's essentially changed since we said save it out here. Now let's say now, over here on the base, it's an hour later. So this has got 10 a.m. data over here. So this is an hour old. So let's say it's 10 o'clock now. Your goal here is you want to sync this up. What this allows you to do when you do save the snapshot is it allows you to sync this up. So let's say it's 10 o'clock over here. We've kept track via the copy space, copy and writes here. That's why this volume needs copy space defined. If you do this, save the snapshot. So let's say it's 10 o'clock data here. What happens is you're going to be able to resync, catch this up. So what happens when you resync this clone up to the base, what actually happens is, remember it's 10 o'clock here. We'll take a snap here at 10 o'clock. Basically compared what changed with the snapshot, what's changed. Catch this up. And then get rid of this old snapshot. Then you can resync it 11, 12. So if you want a full copy every day, you know, resync it. So the reason you would click on this save the snapshot is so that you can resync this clone to get it current. And when you resync it, we create a new one, compare it to the old one, and basically catch this up. Right. So let me show you that. So what I'm going to show you next is how to resync it. So let's pretend here HP2 is a day old or an hour old. Then I would resync it. Resync the clone. It's just going to say, okay. It's going to catch it up. You can't really see this, but it deletes the old snapshot and creates a new one. Then, you know, it's an hour later, then you can resync it again and again and again. All right. So the reason you would click on save the snapshot is you want to keep the relationship between these two volumes so you can sync this clone up and catch it up. Now, a couple of other things. So let's say, for example, remember the data is current as of 10 o'clock here, the base and the clone. You have that 10 o'clock snapshot. We're keeping track of copy on writes. Let's say something happens to the base, like you lose a cage or multiple disks, or the database crashes at 10:30 here. Something happens here. You cannot use this clone to restore the data back. You can't so you can resync this clone up to this, to the base, but you cannot roll this data back. Kind of take the 9 o'clock data and roll it back here. But you can use this snapshot. Remember, this is actually created behind the scenes, but you can actually take this snapshot. Remember, this is my 10 o'clock point in time snapshot. And just like snapshots we talked about earlier, you could highlight this and promote this back here. You can use this to recover. All right. You can use this to recover if you wanted to. But you can't really kind of resync, go this in the direction. Or like if this became corrupt, you can reuse this snapshot to recover the data. Or remember, this clone over here has the 10 o'clock data. You can use this. Now, when there's a relationship though between this base and this clone, you cannot use this data. When this is a clone, there's still a relationship. The clone, we assume that you want to keep resyncing this up, resyncing this up, resyncing this up. So in other words, let's say you wanted to use this actual data here, this clone, to maybe export to a testing server to do some testing. You could not export this to a host. Let me show you that. So remember HP2, it is a clone. It's the clone of HP1. It's going to say, I can't export it because it's being used as a clone. So let's say you want to use this clone and you want to export it to a host. Watch what I'm going to do. You have to Actually, let me change my view. Let me do that one more time. You have to highlight the clone actions and promote the clone. Now, when you promote, this action will change HP2 from a clone to a base, and do you want to promote it? So basically, if you want to use that clone, you have to promote it. All right? Now, let me kind of stop the share. So if you want to actually use this data to maybe export it to a host, it can't be a clone. So what you have to do is promote it. And what promote means this. Promote means take this clone, make it a base. When you promote, it means make this a base. With a clone, you don't need I said earlier, if you want to make a clone, you don't need a license. But to create a clone and use this option, the save snapshot for later resync, you need the snapshot license. So the first version I showed you of a clone where you just copy it from source to destination, don't save the snapshot, that's free. But if you want to do this save snapshot to resync it and, you know, you need the snapshot license. So even though, like earlier, you were using the term split, somebody was using the term split, that's more of like a mirror clone terminology. We're not, this data over here is never real time. It's always point in time. Now you can catch it up, sync it up every 10 minutes or every hour, but it's not a real-time mirror clone. And when I hear you to use the term split, normally in real-time mirror clones and some arrays, this data is real-time, and you have to split it to make this point in time to use it. Our clone is always point in time, and remember, when it's a clone and there's a relationship between the two volumes, you can't even use that data anyway. Now you can make your own snapshots off of the clone, but if you actually want to use this clone, you have to promote it, and then at that point it's point in time anyway. So the only kind of equivalent to a split is a promote, but just basically the data is point in time anyway, and it just makes it a base. So this is just what I showed you, the cloning, and this I showed you choose the base. I'm sorry, you choose the destination, you know, intermediate snapshot. If you use this, save the snapshot, it keeps the intermediate snapshot here. If you use this, oops. Here's the create the clone. You can do the save the snapshot or not. You choose the destination. This is a clone. I'm just showing you a view. Here's the base. Actually, I showed you this. I showed you some of the copies. I showed you with snapshots. This is how you resync a clone up to a base. And I showed you how to promote it to be a base. So I showed you all this. And you can work with clones from the command line as well. Create VB copy to create your copies. Create VB copy minus R is to resync the clone up to the base, and to promote a clone to be a base, it's promote VB copy. So you can work with clones from the command line. You can also work with cloning volumes in a volume set as well. Do a new volume set. So I believe in some of my conversations in some of the other Bank of America classes, you are going to possibly be using our snapshots. Now, you know, this is our version of snapshots. I mean, there are host-based snapshots, VMware snaps, you might be using those, but that's how our snapshots work. It's snapshots at the array level, keeping track of, you know, data. the volumes, the 16K pages and maps, and also with the clones. So 2 types of local replicas that we support in the 3-par array. So any questions on that? On anything we talked about? Today we talked about host sets, volume sets, DO, conversions, snapshots, and clones. Any questions on any of that? Well, let's go over the labs. Use the same logins. There are going to be 3 labs. In the book, it'll kind of say, I got the page numbers here, all right? Yeah. So here in the different boxes, you're going to do a lab on host sets, volume sets, tuning and conversion, snapshots and cloning. So over here, I have all the page numbers you're going to need. So let me go over the labs. Essentially for these labs today, you're actually going to start in your lab guide on page 153 and move forward. So let me kind of show you the labs you're going to do today. So you're going to start on page 153 here. And what I have you doing first is creating a volume set, logging to SSMC and creating a volume set. It's pretty straightforward. I have you doing it, creating new volumes using a count, creating a couple new volumes and putting it in a volume set, doing some things. And then I'm going to have you put your Windows host in a host set using SSMC. So I have you creating a host set. Now what you wind up doing here in this lab is putting your Windows host that you've been working with all week into a host set. So what you wind up doing in this lab is creating a one host set. In most cases, you wouldn't have one host in a host set. But you create a one host set, and then I have you eventually taking your volume set that has 3 volumes in it to your host set, which really only has 1 host in it. But when you go to the host, I eventually have you going into disk management. If your one host in your host set sees the volumes in the volume set, you know it works. Then I eventually have you going out and taking your host out of your host set. I have you unexporting the volume set from your host set, then eventually deleting the host set and deleting the volume set. And then if you want, you can work with host sets and volume sets from the command line. I have you doing CLI things. Okay. Then there's a little lab on DO and virtual volume conversion. And really that part, I have you doing some things at the beginning. You're going to create a couple of new CPGs and a new full vision volume. And then eventually I have you doing some things in SSMC. Skip the stuff on management console. So I have you doing a DO tune and conversion using SSMC. Eventually I have you have a volume tuning it into a different CPG. Then eventually I have you doing some things, doing a DO tune using the same CPG using SSMC. And then eventually the lab has you initially creating a fully provisioned volume, and then I have you converting the volume from a fully provisioned to a thin provisioned volume. And then doing some DO tunes and online conversion using the command line. Eventually highlight using the tune VV command to do DO tunes and converting. All right. Then there's a lab you're going to work with on snapshots and clones. And you really kind of get to start in your book on page 191. And in the snapshot part of the lab using SSMC, you do a lot of the things I did earlier. You know, remember I demoed creating a volume and deleting data and promoting it. And so eventually what they're going to have you do is create a new volume that's 7 gig, export it to your host, format it, get some data out there. Then they're eventually going to have you create a snapshot of the volume in SSMC, and then eventually taking the snapshot like I did earlier, exporting it back to your host, doing some rescanning. They have you do some 3-par infos as well. Then eventually changing some data on the base like I did. Remember I deleted all the volume data on the base and then promoting the snapshot to roll data back. they have you doing some things there. Then in the lab, I have you doing some snapshots using the CLI. If you want to work with the CLI, take advantage of that. And then there's a lab, the latter part of the lab has you working with a physical copy using SSMC, essentially doing what I just kind of showed you, creating a destination and saving the snapshot for later resync and doing some things from the host side of things. And then eventually working with physical copy from the command line, you know, resyncing it and promoting it and so on. So back in the classroom, make sure you follow the page numbers I have over here because, you know, like on host and volume sets, you get to skip the parts on management console in the lab. So, you know, here it's 153, essentially 162. And of course, I have written here the SSMC or CLI. If you're not that interested in the CLI parts of the lab, you can skip them. It's not going to kill you. For the DO and conversion, you're going to start on, you have to do what's on page 164. Then the SSMC part is 174, 180, and the CLI 181. Oops. And then snapshot lab, you want to do the SSMC part 191 and 196 and CLI 197 and 99. And cloning is the page numbers here. You know, so remember, you know, you get to skip like page 200 to 205 because that's all management console things. You know, and you're not going to be using management console. All right. Okay, and you're going to use your same logins that you've been using all week. So that's going to be it for the new material we're going to cover today. Tomorrow's a different day. But it's about 11:40 Pacific time. So the rest of the day is lab time. Some of you might want to take lunch, dinner, whatever you want to call it. But here are the new labs you can do today, just like the past couple of days. I'm going to sit around here this afternoon. If you have any questions or problems, go ahead and right-click and private chat me, then we can take it from there. So tomorrow, well, again, unless we have any objections, class will start, tomorrow's Thursday, at 7:30 a.m. like we did today, Pacific Standard Time. Unless that's a problem. Anybody have a problem with that? Or all right, so we'll start at the same time we've been starting. We started today, tomorrow at 7:30 a.m. Pacific Time. All right, with that being said, that's going to be it. Lab time for the rest of the day. Private chat me if you have any problems. If I don't hear from you, have a good night. Good afternoon. We'll see you tomorrow.